So what I have just demonstrated is the rotation of the core of the armature core of this generator here. This generator in which the rotor, which I'm turning by hand now, you'll see the blue mark, the blue tape here marking one part of its diameter on the winding there, and I'm rotating it through 90 degrees, then to the point that indicated before, 135 degrees from the first point. Right. Again, rotating by hand there, you can see the blue tape moving through 90 degrees, then it stops, it stalls at 135 degrees. The intention is for that rotor to continue to rotate like that, around and around and around, driven by a rotating magnetic field elaborating in these electromagnets. There are 12 of them. These are what you can call the equatorial ones. They're in the equatorial plane of this. There are 8 others positioned superiorly and inferiorly like that. Now, why should these electromagnets drive this rotor core around? The reason is that inside of the core is an array of electromagnets, permanent magnets, in a helical form, right? Which I'll demonstrate later on some paper. So what you saw before was what happens when I connect those. Where's this? connect those electromagnets to this 12-volt battery, and that causes the electromagnets, which are 12 electromagnets in parallel circuits from this battery, turn on and rotate the act on the magnetic core inside the generator to rotate, right? The problem at hand is that in order to make the rotor with this magnetic core constructed of permanent magnets, bar magnets in a helical array, which I'll show you later. The problem is that in order to make that happen, the polarity in the electromagnets has to change, has to be flipped by reversing the current in them using a switch, using an electronic switch, which for the components of which I have. Right. So without that switching, the core can be rotated 135 degrees. That is through only part of the cycle. But if with the capacity to switch to reverse those the direction of the current using an H bridge configuration in the electronic switch, the core should be able to rotate through the full 360 and continue to go, right? Having succeeded in doing that with the use of this switch, which is still to be built, that's the problem. I don't know how to wire up this switch. It requires electronics expertise, which I don't have. Then what is expected is, because we have a situation with this generator where you have 12 electromagnets driving effectively a propeller, a magnetic propeller, one side of which is north, the other side of which is south, driving it around using the switch. What is expected is that because there's therefore a continuous magnetic field flux dynamically changing due to the relation between the external field coils and the interior core. What is expected is that a copper winding, continuous singular copper winding around the core being driven by the external field through this integrated field. There should be a current generated in that winding, which would be here are the two ends of the winding coming out using brushes on the axis, on the axle, down in here. So some sort of current should be generated in that winding. That's the purpose of the experiment. It's an experiment, experimental apparatus. I'm calling it a generator for that reason, that there should be, the aim of it is to determine the nature of the current generated, produced in that winding, if any. Given the setup, the configuration of this generator, you might at first expect an alternating current, but because we're switching the polarities in the electromagnets at various positions at various times during the rotation cycle, it may turn out to be a sort of a homopolar generator, giving out a DC, a direct current, as if to say that because the central core is a sphere, the spherical form, within which the permanent magnets form this helix within this. I call it a spherohelix, for want of a better word, a term. But it's possible to imagine the winding around this spherical form in a particular way. It's a lap type continuous winding. I'll show this on the whiteboard later. It's possible to imagine a whole series of disks in the typical classical homopolar generator, DC generator, stacked on top of each other in an incrementally progressive relation to each other with respect to the current being generated in the components of the winding, which would constitute the exterior rim anyway of such a disk, not the whole disk. So something like that. It's possible to imagine that, in other words, that you could get a DC current out of this, but at first you would expect an alternating current to be generated in here. Now the purpose of the experiment is to determine the nature of this current. Because this winding is passing continuously through a continuous magnetic field, changing magnetic field. There's no point in the winding which is not exposed to that field. At no time is it, it's continuously exposed, right? So the nature of the current, particularly an alternating current, might suppose that it would have properties different to unlike ordinary alternating current generated in a typical loop configuration with two magnetic poles, the typical scenario for electromagnetic induction. Right. So the aim of the experiment fundamentally is to determine the properties of any current generated in that winding, which is being driven with the core. It's mounted on the core, the magnetic core, being driven through this integrated field, right? An oscillatory thing. So that's it. As you can see, it's the housing for all of these parts of the generator. It's wood, the wooden housing, the electromagnets, are thus, there are 12, right? So if the interior core is spherical, then the electromagnets are positioned at the midpoints of the 12 sides of the cube with the same center as the spherical core. So you've got 12 electromagnets directed at 45 degrees to the cubic face planes, right? 12 of them directed at the center. And each of those electromagnets is wired in parallel to the battery and is drawing about 50 amps each of current, which is sufficient for the purposes of the demonstration. Now, with respect to the propulsion of the core by these electromagnets, the reason that they're positioned as such is basically because the internal core is configured as a helix such that beginning with the diameter for each 1 degree of rotation of the next component, the next bar magnet elevated, it will be 1 degree elevated. So after 45 degrees of rotation in the structure of the core, it'll be 45 degree elevated, and therefore in line with one of the electromagnets positioned on one of the top edges of the cube. And similarly, for the lower, the inferior electromagnets, 45 degrees down and around, right? And by the time you've rotated 90 degrees, you've come to the top of so it's a spherohelix. I'll show you this with you. Yeah, so that's the specific reason for with respect to the propulsion. Quite apart from what you would expect to be generated in the winding, that's the reason for the geometrical position of the electromagnets, right? So the practical problem in getting this interior core with a north side and a south side constructed of permanent magnets, a spherohelical magnetic core. The practical problem in getting it in propelling it using these electromagnets positioned as they are, is that, so if we begin with, I'll put this on the whiteboard to make it clearer, simpler, but the general idea is that when the north side of the core, with the winding around it, with the core is positioned at one of the equatorial electromagnets, call it north polarity of the north side here, then that will be repelled. At the same time, if this electromagnet at 90 degrees is with a south polarity, then that will attract, right? And the opposite on the opposite side. If this side is north, the opposite electromagnet will be south, and that'll do the same, have the same effect for the south side of the core. Similarly, that will be repelled from there and attracted to a north on the other side, opposite to the south here, right? The problem is, once it's attracted there, this south that's attracted the north side of the core needs then to flip polarity in order to keep repelling it. And as you've seen, otherwise the momentum of the core carried to 135 degrees, halfway between this, because the other ones, the opposite side will be attracting it as well. So it'll stall in between these two electromagnets, both at south polarity in that case, because this, and the only way this second electromagnet, the polarity has to switch at the same time as the ones opposite, and not just those two, but in this, because of the form of the core, the other 4 electromagnets, 6 in total, have to switch at the same time, and then they have to remain that way for 180 degrees of rotation until they switch again. And the other 6 have to switch 90 degrees of core rotation later, and then remain the same way for 180 degrees. So you've got 2 sets of 6 electromagnets, all both in 2 main parallel circuits. All the electromagnets are in parallel. So they need the electronic switch in those there have to be 2 H-bridge switches in 2 circuits to those 6 electromagnets, and they need to switch at at different times, which can be programmed using an MCU. Right. So the problem is building the switch, which would then be inserted, two switches inserted into the 2 direct current circuits to those electromagnets. That's the technical problem here, to get this core to rotate continuously through 360 degrees again and again, right? And that's the purpose, essentially, of this video, is to enlist the technical expertise of someone interested enough to get themselves involved in this project. For the time being, right? So to repeat, it's essentially an experiment to determine the nature of the current generated in this generated here. Okay. So I'll go now and demonstrate a couple of things on the whiteboard to clarify some of the details about the structure of the core and the mechanics of rotating it using electromagnets and alternating their polarity. Okay.